All right, this is lesson 3.3, function notation. So function notation is just a format of how you write this equation. It will look very similar to slope-intercept form. So write the vocab for function notation. If you look at it, here's the definition. So it's another name for y. Instead of you seeing the variable y, you're going to see f of x. See the little f with the parentheses x? That's telling you the function of x, or the value of f at x. We're going to get into this a little bit more, but the Cliff Notes version of this is just think of f of x in place of y. So it's just another label. So that's all you really need to think about. So when you see f of x, think that's the y place value. It will make a difference later when we're plugging in the values. Okay? And you guys did notice, let me go back to that. Right here, y equals 5x plus 2. That's slope-intercept form, correct? Yeah. So the function of x is the same. This would be f of x equals 5x plus 2. All right, do you need more time to write the vocab? All right. Oh, I just said all that stuff. So let's do example 1. So we're going to evaluate f of x at negative 4x plus 7 when x equals 2 and x equals negative 2. So when it says evaluate, what is that telling you to do? To solve? Yep, to solve it. So we're going to find two answers here. Why are we going to find two answers? Because it gave us two values to plug in. Yeah. So we're going to evaluate f of x when x equals 2 and negative 2. So let's write our first equation. And then we're going to plug in the first value that they gave us, which is 2, wherever the x is. You'll notice that we do plug it in the label of function at the beginning, f of x, because that's telling me when I plug in 2 to this equation, this is going to be my answer. So you're not actually solving f parentheses 2. You just leave that there. You're solving the right-hand side, okay? So now we're going to simplify this. What's negative 4 times 2? Negative 8 plus 7? Negative 1. So then f of 2 equals negative 1. Okay? So now let's do the right hand, the other variable. So we're going to plug in negative 2 in the same spots. And remember, the stuff in front of it is just a label. So now we do negative 4 times negative 2, which is 8. Positive 8 plus 7? 15. So when x equals 2, f of x equals negative 1. And when x equals negative 2, the f of x equals 15. So this is how you would write your answer. It's a little more lengthy when we're dealing with functions. Okay?
Yes.
Got it?
Yes.
I'm just giving you time to write. Because I see you're all still writing. Not while I'm lecturing. Everybody got it? Okay, let's look at example 2. Now, you see here, hold on, where's my face? Gotta let it update. There you go. That our function is a function of what? Look at it. What's at the top? F of t. So you will see that function of t, you'll see different variables in the parentheses, okay? In math, what does t typically stand for? It can be temperature or time. Those are the two possibilities. Time is usually a capital T, whereas temperature is a lowercase t. So it says, let Ft be the outside temperature in degrees Fahrenheit and T hours after 6 a.m. So T is the number of hours after 6 a.m. Explain the meaning of each statement. So let's look at this. F of 0 equals 58. So if T stands for the numbers hour after 6 a.m., For A, how many hours are we after 6 a.m.?
0.
0. So it is currently what? 6 a.m. And what is the temperature? 58 degrees. All right, so now let's look at B. F of 6 equals N. So what is this telling us? It's 6 hours after 6 a.m.? Is noon. Very good. And the temperature is what? N degrees. So you would label it N degrees Fahrenheit. Okay, and then the third one, F of 3 is less than F of 9. So what is this telling us?
3 hours after 6 is cold, and 9 hours after 6.
Very good. 3 hours after 6 a.m. is going to be colder than 9 hours after 6 a.m. You could also plug in the hours. So 3 hours after 6 a.m. would be 9 a.m. And then 9 hours would be 3 p.m. So F of 3 is 9 a.m. So you're going to say 9 a.m. is going to be colder than 3 p.m., which makes sense. The sun's up higher. Okay, so in these situations, you're just kind of giving me an explanation. And there's probably a couple different ways you could write it that would still be true. So you guys don't have to have identical answers when you do that. Any questions on how we're looking at these? You might not, because you might say it slightly different than they do, but it can still be a correct answer.
Wait, how did you write it again?
So I would have said 3 hours after 6 a.m. is colder or less than 9 hours after 6 a.m. But you could also have said 9 a.m. is going to be colder than 3 p.m. because that's the solutions of those functions. Good? Excellent. I'm going to guess you're doing your monitoring progress now. Yep, 1 through 3. So work on that. All right, so now let's do example 3. For h of x equaling 2/3 x minus 5, I don't know why I said it like that. Find the value of x for which h of x equals -7. So again, h of x is just another label for a function. Okay, I know f of x was function of x. That made sense. H of x, it is still a function. Just think of it as a label. So what are we going to do here?
So you're subbing -7 for h of x?
Correct. So you're going to plug in -7 wherever that h of x is.
Plus 5 on both sides.
And then, yes, we add 5. And then, Chloe?
And then you would do times these two on each side to get rid of the...
Very good. Multiply 3 halves. You get x equals?
-3.
Yes. So when h of x equals -7, x will equal -3. Or vice versa.
Wait, didn't you just do -2 divided by...
Divided by 2/3, yes.
That's just like better.
Technically, flipping and multiplying is what you do with fractions, so that's a good way to think of it mentally. But on your calculator, yes, division works. All right. Let's look at example 4. All right, so now we're going to graph. Go ahead. F of x equals 2x plus 5. Is this in slope-intercept form? Yeah. So are we able to graph it?
Yeah.
Absolutely. I don't need you to make a table unless you prefer doing it that way. I don't. As long as it's in slope-intercept form, we can graph it. But if you make a table, pick at least three values and solve. So, but for us, look at this. Where's my y-intercept?
Oh, your y-intercept.
What's the y-intercept on 5?
Yeah.
So I can put a dot here at 5, which makes sense because look here. When x equals 0, y equals 5. And then, so it'd go right there. And then what's my slope?
Your slope is adding. So it's going up.
No, what's my slope?
2.
Oh, 2.
2. So I go up 2 over 1, which you see there, they have a second dot. So first dot can go here, second dot can go there.
And it's already...
Connect it, done. You only have to have 2 points on a graph to be able to sketch the line.
It goes minus.
then you would go down 2 over 1. It'd be a negative slope instead of a positive slope. Now, if you prefer making the table with 5 points, you may do that as well. Whichever way your brain likes it. As long as you know how to graph it. All right, is this a constant rate of change? Yes.
Yes.
Yes. No. All right. You want me to go ahead and do example 5 real quick? So that way you're not waiting on me? All right, let's do example 5. And you can go back and do the monitoring progress. All right, this graph shows the number of miles of a helicopter is from its destination after X number of hours on its flight. On its second flight, the helicopter travels 50 miles farther and increases its speed by 25 miles per hour. The function, f of x equals 350 minus 125x, represents the second flight, where f of x is the number of miles in the helicopter. I need you to whisper. Gentlemen, y'all got to whisper. I shouldn't be yelling over you to teach. So that equation is representing the second flight, where f of x is the number of miles the helicopter is from its destination after x hours. Which flight takes less time? So we need to look at the first flight, which is represented by this graph, and probably compare it to the second equation right here that we have. So let's graph the second equation that we have. Is this written in slope-intercept form?
Yeah.
Yeah. So it's easy to graph, right?
Well,
Go ahead.
do you just switch from 25 to 350? So it could be like point on instead of point.
I don't understand.
Like, you know, in the worksheet how we switch numbers to make it y equals mx plus b. Do we trade 125?
Oh, yes, you would. You would. She's asking, do I need to rearrange this negative 125x in front of the 350? Yes, to make it easier for your brain to graph it. Do you have to write it that way? If you know that in this equation, 350 is the y-intercept and negative 125 is your slope, you don't have to write it differently. I like it because my brain needs it in the right order to graph it. Okay, they made an input-output table. Again, this is the y-intercept, which makes sense because x is 0. And my slope is, it goes down 125 every one value. So if I were to graph it, I would start up here at 350. And then I went down 125 over 1. Down 125 over 1. You see it crosses nicely right here at 102. All right, so now that you have the second line, we can compare it to the first line. So when you look at the first flight, you see that when f of x equals 0, how long did it take us? How many hours? Right here. 3 hours.
3 hours.
And in this case, when we were at 0 here, how long did it take us? Exactly 3? Slightly less than 3. So which flight is faster? The second one. The new line that we just drew. Now you can check your answer by plugging in 0 here where this little arrow hits the x value. Go ahead. You can plug in 0 here and solve it so you can find out exactly what it is, 2.8 instead of 3. So it took us 2.8 hours, not 3 hours. So the second flight is faster. It was really all they're asking you. Okay? So you could actually graph it or solve it algebraically. Either way. Algebraically, you would just plug in 0 where the f of x is, solve for x, and you'd see here that we flew that flight in 2.8 hours, whereas the first flight, we flew it in 3 hours. Question?
You don't have to graph it.
I don't graph unless I have to. I algebraically solve things. Yeah, so that'd be fine as well. Any questions on how we did this? Awesome. All right, so you guys need to finish monitoring progress all the way through number 9, and that's it.